Before we start remembering a whole lot of stuff wrong, let's fix a couple of things. I'm hearing a lot of stuff like, I kind of remember seeing this, and I don't remember exactly what to do. It looks somewhat familiar. If that's where you're at, that's probably a pretty good spot. Okay. You should be somewhat familiar with it, at least recognizing that these are rational functions. We're going to talk about rationals today in 1.7. So like I said, at one time I said unit 1 is a lot of algebra 2. We're trying to get it all in basically the first unit. Some of the stuff that we do is, I don't want to say it's algebra 2 topic, but we're taking it to the pre-cal, the rate of change, increasing, decreasing, things that, you know, you kind of know, but you didn't really realize that you knew. This stuff here, hopefully, again, as we start going through it, it starts clicking and ringing bells, right? This is a rational function. The reason why it's a rational function is because you have a polynomial over a polynomial, okay? So if I just gave you 2x squared, 5x, and 3, that's a polynomial, right? It's a parabola. We know it opens up and it has it could have 2 intercepts, maybe just have 1, right? Probably not with a 2, but it could have 2 intercepts, may not have any. If it does, then it has 2 real zeros or 2 imaginary zeros. But again, all that stuff we kind of already know. And then the denominator is also a polynomial. That's actually a difference of squares. And then we realize, or hopefully at some point between the conversation that y'all had, you realize that if the denominator is 0, we got issues, right? Because we know that we can never divide anything by 0. And so those are domain restrictions that you really need to, you know, understand all that stuff from Algebra 2 now, because those domain restrictions are going to be really, really important to us, okay? The first question says the x-intercept. So the x-intercept is whenever the top is 0. Whenever the bottom's 0, that's bad. There's no such thing as a bottom 0. In fact, I guess that ends up being vertical asymptotes, if you guys can remember that. Okay? Well, the top, whenever the top is 0, that's when we have x-intercepts. And unfortunately, they led me with a leading coefficient of 2. And you guys got to start getting, I mean, this should be factoring like, boom. You should almost look at that really quickly and be able to factor that, okay? And if you can't, find stuff to make you practice, okay? Or I'll try to find something for you. But like I said, you should be good at knowing that this is going to be a 2x, and this has to be an x, and I need a 5. There's 2 ways to get 5, so this is kind of tricky, but they have to be different signs. And so if I put a 3 here and a 1 here, that will be a -6 and a +1. And you should almost be able to factor it that quick, okay? If you can't, whatever tricks you do, or I don't do any tricks at all. 2 can only be 2 and 1. That's the only thing it can be. So I know one of them's a 2 and one of them has to be a 1. And 3, luckily it's 3. It can only be 3 and 1. It could be 3 and 1, or it could be 1 and 3. And so I just make my little happy face until I get a -5. And what I mean by happy face is the outers and inners. And when the outers and inners end up being -5, I'm good. And so it's a puzzle, if you will. It's a mathematical type. You know, we all do these Wordles and these other things, right? The daily puzzle. That's just a puzzle. You're trying to get that negative. And if you can't get -5, then it just doesn't factor. Right? Most everything we do in this class is going to factor. We don't want to spend the time to use the quadratic formula, because if I use the quadratic formula, that really doesn't help me a whole lot until I need to find imaginary zeros, and imaginary zeros mean nothing to us really. So most everything's going to factor, because if it doesn't, we're going to be using calculators. Okay, y'all good with all that stuff? So that should be pretty, I won't say, you know, immediate. I understand oh, I can't do it that way on this. Sorry. We should be really good at factoring, like I said, by some point, okay? And get your practice in if you can't. Oops, went too fast. There we go. This one's nice because that's just a difference of squares, and we have x plus 3. Whoa, sorry. Gosh darn it. Undo. I can't fix that. Can't fix it. X plus 3, x minus 3, okay? And so when we see a rational function, chances are really good you're going to have to factor the top and factor the bottom. Chances are really good you're going to have to do that because that's going to help us do some things, okay? Now I can see pretty easily that -1/2 is a 0. -1/2 is a 0. You set the factor equal to 0. So if you have to, I mean, I'm figuring most of you guys are pretty good at this. You've done, but you're setting 2x plus 1 equals to 0. Okay, because if that's 0, then the top 0, no matter what x is on the other side. It's called the zero product property. Okay, because 0 times anything we know is 0. So if this is, I'm sorry, if the left is 0, I don't care what the right is. So if it's 0, well, we subtract 1 and divide by 2. That doesn't take a whole lot of mathematics, but if you need to do that, go ahead. X is equal to -1/2. You probably, like I said, have done that enough in Algebra 2, you probably can do that in your heads, and that's okay if you can. So that's a 0. What is it? So that's an x-intercept. X-intercept, 0, root, they all mean the same thing, okay? Now, 3 should be a 0 or a root or a x-intercept. However, we have x minus 3 on top and x minus 3 on bottom. And we already learned, I'm pretty sure that you guys know that x cannot be -3 and x cannot be +3, because if it does, it gives me 0 on the bottom, and that's bad, 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 bad. Well, if I set x equal to 3 up here, I get 0 on the bottom, and that's bad. So these two things are factors. They kind of cancel each other out. But x still can't be 0. X still can't be 0, because if it is, it gives me 0 on the bottom. Sorry, x still can't be 3. Okay? So 3 is not a 0. 3 is what we call a whole. If you guys, I don't know how much y'all got into the wholes and the canceling, and then like when the numerator was bigger. I heard a couple of Bobo Bottons, Bobo Botton and each DC something, yeah, whatever. Hit me. How does 1 and 1 and 3 doesn't, but 6 and 1 do. Outers are 6 and inners are 1. It's a common thing. That's why a lot 1 and 3 won't give me 5. No, 1 and 3 don't, but you have to count the 2. Okay, so let's see. Vertical asymptote is at -3. Okay, when you write a vertical asymptote, it should be x equals -3. We don't just say -3 because vertical asymptotes are equations, right? Again, +3 should be a vertical asymptote, but because I have a +3 here and a +3 here, it's not a whole asymptote. It just can't be 3. It can't be that one dot. Okay. Again, we'll teach a lot of this, but I'm trying to see kind of how much your Algebra 2 guys taught you, right? I think it's one of those things that they probably said, and they may have went over, but they probably said you're going to learn more about it in pre-cal. That's my guess. That's what I do when I did. Okay. All right, so that's your vertical asymptote. There is a hole at 3. I don't know where 3. Well, actually, yeah, we got to plug it in. You got to plug it in to see where it is. But you can't plug it in here, because if you plug it in here, you're going to get 0 over 0. So you got to plug it in here without that part of it. Don't worry too much about that, but as long as you know, if you know that there's a hole at 3, you're good right now. Okay? As long as you realize there's a hole at 3, and it's because there's a factor over a factor. Okay? And then it says the y-intercept. The y-intercept is probably the easiest one in the world, because all you got to do is plug in 0 for x. Right? Anytime you want the y-intercept, you plug in 0 for x. So if I plug in 0 for x, well, that's 0, and that's 0, and then we have -3 on top. And if I plug in 0 for x on bottom, that's a 0, and that's a -9. So basically, you have a -3 over a -9, and -3 over a -9 is a +3 over a +9, which is a +1 over a +3. So the y-intercept should be 1/3. Okay? And we typically, when we write intercepts, I write them as 0, 1/3, because that's what the x value is. I mean, that's a point. It's a point, right? So y-intercept should always plug in 0 for x, find y-intercept, no matter what it is. No matter what your function is, you plug in 0 for x. Horizontal asymptote, if you guys can remember now, the degree on top is 2, the degree on bottom is 2. This you should know. If the degree are the same, basically you don't look at this, 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 and you don't look at this, you look at the coefficients. You look at the coefficients. And so I have a 2 over a 1, and simply 2 over 1 is 2. And so the horizontal asymptote should be y equals 2. Okay, horizontal asymptotes are also equations. Vertical asymptotes are equations. Okay, so that should be at least a, I don't want to say bell ringer, but something to kind of tip your head. Oh yeah, I remember that now. And that's the BOBO, bigger on bottom. Bigger on bottom, it's at 0. If they are the same, then you have to look at the coefficients. And again, you don't look at anything else. You just look at the degree. Be careful of that now. Pre-cal will mess you up sometimes, and they won't put the biggest, the biggest exponent first sometimes. Okay? So just make sure it's the degree 2 and the degree 2. So you look at the coefficients, 1 and a 2. And so that's lucky. 2 over 1 is simply 2. So I know that I have a vertical asymptote. Did it even ask for the vertical? Oh, it did. It asked for the vertical. So here's a vertical. Here's the horizontal. There's the y-intercept. I got a hole somewhere at 3. Okay? And so I could at least come close to sketching a part of this. And I'm not too concerned with the sketching part of it yet either. You good? Anybody got a question over this? Ring some bells, yes. If you know there's a hole there, then we're really good. I don't think you need to really know that. I think that's more of a pre-cal issue, okay? Knowing that the zeros where if you put 3 as a 0, I could get it. I'm okay with it. But if you can factor that, you're pretty good, right? If we can factor this, we're good. Knowing that it can't be 0 on the bottom, you're good. And if you knew that the degrees were the same and so you had the horizontal at 2, you'd be pretty good. Y'all okay with all those question statements? Good. The second one, I think it goes. Yeah, there it goes. We need to factor the top because it asks the same questions. X-intercepts, vertical asymptote, horizontal asymptote, holes, and y-intercepts. So we should be able to factor the top. So factor the top, I'm going to take an x out first. And then I have an x squared plus 5x minus 24. And that doesn't help me. So, that gets me started. So hopefully now we get an x and an x. It is 5 and 24, isn't it? Yeah. 24, 6 and 4 won't work. 12 and, does that factor? 8 and 3. Okay. And they both, let's see. So 8 needs to be a big one, and a 3 needs to be a negative one. Okay? Everybody good? Told you, most of these will factor. And then I'm going to take an x out of the bottom, and I'm just going to be left with x plus 6. That was really easy to factor, I hope. Okay? And so intercepts should be at 0, should be at -8, and should be at +3. That's where they should be. It is at -8 and +3, but it's not at 0 because we have a 0 on top and a 0 on bottom. And so that can't be an intercept, because if you have 0, then you have 0 on the bottom, and that's bad, and we can't ever have 0 on the bottom. So those cancel out. So again, as the last question now, hopefully you know that 0 is going to be a hole in this graph. And what I mean by hole is it's continuous till it gets there, and then basically there's a hole, and then it just keeps on going. That's what I mean by a hole. Gosh, what's the mathematical term for it? Yeah, removable discontinuity, a removable, it's where it was continuous and now it's not continuous, so it's discontinuous. Discontinuity. It's continuity. I think it's a removable discontinuity here. It doesn't make it continuous. It's a hole. I just like to call it a hole. Okay? And then the next thing I think really important, of course, the x-intercept, the y-intercept is really easy. Again, we plug in 0 and we'll just get 0 over. There's not a y-intercept. There's not a y-intercept because that's where the hole is. The hole's at 0, 0. If I plug in 0 on top, I get 0. And if I plug in 0 on bottom, I get 0. It's not at 0, 0. It's at -24. It's at -4. Let's plug in 0 down here. Okay? Not concerned that you don't know that. And then the thing Like, I'm not too sure how much you guys did this in algebra 2, but the degree on top is bigger. Bigger on bottom divide coefficients. I don't do Bobo botany. I just divide. I divide. X squared will go into x cubed, x times. So this has a linear oblique asymptote. If it's bigger on top by 1, it's got a linear asymptote. Okay? If it doesn't go into it, it's 0. Like the previous one, it went into it. That's all. And like I said, I don't do this Bobo button stuff. I just divide. X squared goes into x squared. Let me rephrase that. X squared goes into 2x squared 2 times. So it's at 2. And so I don't have to remember any acronyms. I just divide. If it doesn't divide, it's 0. And if it does divide, divide it. If it's 2 more degrees, you're starting to get out of pre-cal lessons, because it's like a quadratic asymptote, which is like, we're really getting crazy stuff then. Yes, no, y'all kind of remember some of that stuff. Good. Here we go. Let's talk. Let's go to 1.7. 1.7. If you're good with all that stuff, guys, you're going to be further along in this lesson. Okay? We'll talk about most of this. But let's go with 1.7. Okay? All right. A rational function. So, like I said, we've talked polynomials. We talked quickly about a little bit quadratics, I guess. We talked about polynomials. So now we're going into the rational portion of it. That's why we stop at 1.6 to at least have a test now. Okay? I was gone all weekend. I put your test in a drawer, and I'm going to get them out as soon as prep starts. And they should grade pretty quickly. So a rational function is simply a quotient of 2 polynomials. It's a quotient. Quotient is a division problem. Okay, it's an answer to a division problem if you want to. Remember, you got these words: quotient, product, difference, sum. Right? Those are things you sometimes see on like the ACT or something. You learned it at some point, and when am I ever going to need that? Well, you need to know that the word quotient means division. That's why they put fraction. Fraction means division. But 2 polynomials. And so they like to do this a lot, just to get our mind thinking, right? They put f of x on top, and they'll put g of x on bottom, telling me that f is a polynomial and g is a polynomial. Okay? And so we kind of just separate these as 2 separate polynomials. Right? Everything you know about the polynomials is still true. Guys, thanks. So f of x, g of x are both polynomials. And then it says, it gives me the big thing right here, g of x can't be 0. And you guys already knew that. We can't ever have 0 on the bottom. You knew that before you even started doing math. So the following are examples of rational functions. Y equals, why they changed it back to y equals, not f of x. I guess they didn't have 4, who knows. But they got 2 over x minus, or x plus 3. That's a pretty easy rational function. This one starts to get a little bit more crazy, right? X squared, 3x1, and then 3x plus 4. And then this one's even crazier, because you possibly have 3 vertical asymptotes, but you got 2 zeros, and so that starts to get really messy, right? And we can make these look really, really, really messy. We're going to make them look really messy, but you just kind of have to understand, of course, as you start making them a higher degree polynomials, you're making the rational function that much more difficult. Okay? What we're really going to focus on today, guys, is the end behavior of a rational function. The end behavior of rational functions. And the end behavior is going to pretty much determine what the horizontal asymptote is. okay? If it has a horizontal asymptote, as I'm going out, as you guys, this is positive for you guys, as I'm going out towards infinity, I'm just getting closer and closer and closer and closer to that asymptote without crossing it, because it can't ever be that value. And it doesn't ever jump it. Not for a rational function. It can cross it, but it doesn't when it goes out to infinities. So it can cross it all in the middle somewhere in here. It could cross it. It could jump it. It could do some crazy things. But as we're going to infinities, we're just getting closer and closer and closer to them. Okay? So that's kind of what you need to think about the end behaviors. We're not going to infinities anymore. We're going to asymptotes. We're going to asymptotes. Okay? So the end behavior of a rational function is determined by the leading terms. I don't like the leading terms because the leading terms, they might not put it in order. The degrees of the numerator and the denominator. Yeah, the leading terms. And so case one, the leading terms have the same degree, right? If they have the same degree, we're going to look at the coefficients. The coefficients, A over B. And so that's why they're telling you it's A over B. Again, I just divide it. I divide it and I don't have to worry about the leading term. I just look at the degree. Okay? If it's less, if the numerator is less than the denominator, then it's at 0. Again, that's the Bobo, bigger on bottom. It's at 0. Bigger on Bobo. Bigger on bottom 0, I guess. I don't know. The Bobo thing's not mine. I don't know. Like I said, I've never used it. And if it's bigger on top, if the numerator dominates the denominator, then it has an end behavior of whatever the degree is minus 1. So you look at, I'm going with this because I'm supposed to. I don't know. If the degree of the numerator is exactly 1 more than the degree of the denominator, it has a slant or oblique asymptote. If it's more than 1, then it starts, like I said, we're not going to deal with those. We're not going to deal with those. I guess as long as you know it's not oblique. Y'all okay with what I'm saying? So if it's more than 1 degree on top, it's not oblique. And that's all you have to, they're concerned, do you know it's oblique? Do you know it's at 0? Or do you know it's at the coefficients? And those are the only things it can be. You can only have an oblique. Well, let me read 4 things, I guess. You can have oblique, you can have a 0, or you can have the coefficients, or not one of those. How about that? Okay? Oblique, 0, coefficients, or not. And if you know that, you're good. So that's what all this stuff is saying, to give you some kind of notes, I guess. Here we go. Example 1. Determine that the following rational functions have horizontal asymptote, slant asymptote, or neither. Good enough of what I'm saying, right? It has a horizontal, it has a slant, or it doesn't. So that's what they want you to know. Does it have a horizontal, does it have a slant, or does it have neither? If it has a horizontal, write the equation of the asymptote. So we don't even have to find it if it's an oblique, which is nice. Pencil, different color. Gray. A, degree on top as a class. Who? Thank you. Degree on top as a class. Degree on bottom as a class. So we need to look at the coefficients. And I look at a 3 and I look at a 5 and it doesn't do anything, and I'm just going to put y equals 3/5. And if you want to, you can say it's a horizontal. Because that's what it asks, right? You got to look at the question, make sure you answer the question. ATQ. You'll hear me say that all the time. ATQ. Answer the question. ADQ. Answer the question. Good enough? That's what somebody, y'all asked me, do I need to do this on a test? I said, answer the question. Just answer the question. Degree on top is, as a class? Degree on bottom? So it's less on top. It has to be a horizontal at 0. Good enough? Careful how you breathe horizontal. Thank you. Thank you. It takes some of y'all a little bit longer. Letter C. Horizontal. Okay. She didn't get it yet. It come to her. You get it? Okay. Okay. Degree on top. 2. Actually, I don't really care what the numbers are. Its degree on top is bigger. Okay. So it's not horizontal. It's bigger by 1. So it's a slant, oblique. I don't care what you call it. If you want to sound nerdier, you say oblique. And if you want to just know what it is, you put slant. I can't spell oblique, so I probably put slant. They didn't put oblique up here. They put slant, so I'm going to put slant. Do I know where the slant is? Yes, but we don't. So we don't have to because they just said if it's okay. Y'all good? Next one, letter D. Letter D. Uh-oh. Let it catch up. Degree on top and the degree on bottom are the same. So we look at the coefficients. A bad habit for students, especially when I taught this in Algebra 2, a lot of times they say, okay, the degree on top is the same. They put it at 1. No, it's not at 1. Make sure you look at the coefficients. Look at the coefficients. So this one is horizontal. Y equals 1/2. Always put them as equations, guys. Always put them as equations. Okay? Asymptotes have to be equations. You can't just put 1/2. If you tell me 1/2, I don't know what the heck you're talking about. Ooh, a little bit different. The degree on top is 0, so it's less no matter what, right? So this one's at y equals 0, horizontal. Bigger on bottom. Divide, again, divide. Oh, that one's a little bit harder to divide, I guess. 8 goes into 4 1/2 times. This one doesn't divide. This one doesn't divide, so it's at 0. Okay? As we start doing this, everybody thinks, oh man, there's more zeros than there are. No, there's really not more. There's actually more non-anything. If I start just making up stuff, I can make up a whole lot more that are non-zeros. But that's what we focus on in this class. We start getting too much and you almost have to use calculators because why would you not? All right. Write limit statements. Again, get comfortable with writing these limit statements on your AP exam. Number, I forget. Well, I'll know by the time we get there, but one of the numbers, you have to write the limit statement. I'm telling you. And if you don't write it correctly, you're getting dinged. Left and right, they look the same for the most part. You got LIM. You got X goes to. And then you got LIM, X goes to. All right, so this is kind of littler, right? You have to write it somewhat correct. Miss Mims graded this question last year, and she said if they didn't write it correctly, if they put f of x or put an equal sign in the wrong spot, they didn't get the point for it. So you have to write it correctly. Left, this will be negative infinity. Right will be infinity. This is f of x, so I'm going to put f of x. And I'm going to put f of x. I'm going to put equals. F of x is kind of, f of x should be as big as the limit and the x. This is like scrinched. You'll kind of, as long as you get this underneath it and this f of x is kind of bigger than all this other stuff, you're okay. All right? So as I'm going to negative infinity and then as I'm going to positive infinity, and so now I got to look at these horizontal asymptotes. And the one on top and the one on bottom are the same. Going to have to look at the coefs, and the coef of 2 over 6 is 1 over 3. And so the horizontal asymptote is at 1/3. And I don't know what all's happening throughout all this middle stuff, but I don't care because all I care about is the end behaviors. And as I'm getting closer and closer to the end behaviors, I don't know if I'm coming from the top or I don't know if I'm coming from the bottom, but it doesn't matter. I'm still going right to it. So both of these are 1/3. Okay, both of them are 1/3. And those should be, the 1/3 should be almost like the size of the f of x. So these are kind of like big numbers or whatever you want to call it. F of x and the 1/3 should be close to the same size. And then the limit and the x should be the same size as like the f. Close, right? As long as it's close. Like mine's not, but it's good enough. Hit me.
As x going further and further away from 1/3,
That's what it's going to end up as it's getting further and further.
Because like when you write as x goes to negative, then you go to infinity.
No. Well, did you graph it?
Oh wait, no, yeah, I understand that.
No, okay. I'm glad I could help. You almost had me second guessing myself. Obviously, that's the look on my face. Somebody else said something. No, yeah, you have to be approaching it. You have to be approaching the asymptotes as they're going either way. I'm trying to think of one that doesn't, but yep. Can't go over here because then you guys can't see it. And if I go over here, it doesn't go on the board or goes on my website. Were you going to give me a new page? I could have just hit the. Okay. Right, 1/3. Close enough, whatever. I got horizontals in there somewhere. I got verticals in there probably somewhere. Making all this stuff. This is going off of what we. In here, it might do all kinds of crazy stuff. Who knows what, right? And as I'm headed this way, I'm probably getting closer and closer to asymptotes. So I'm either going way up or I'm going way down. But as I'm going out and out, I'm either coming from this way or I'm coming up this way. But either way, I'm getting closer and closer to that asymptote as we're going to infinities. Okay? As my end behavior, this is clearing this up just to make sure. As we're getting all the way out here, we're just getting closer and closer to that line. We go ahead and say we get there. Even infinity is a made-up number. There's no such thing as infinity. But if I did get to infinity, I would get to 1/3. And so that's why we say as we're approaching infinity, we're getting closer and closer to, because that's what it is. The limit as I'm going to negative infinity, I'm getting to the 1/3. Okay. And then again, it does all this crap in here, who knows what. And it's somewhere up in here. I'm probably either starting from way up here, I'm starting way down here, and I'm doing that, or I'm doing this. And like I said, it's possible for me to cross it and come back up. But either way, as I'm hitting infinity, I'm getting closer and closer to that 1/3. Yay, 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 yay. Hopefully that just reiterates what I've been saying. But okay. Here we go again. Limit x goes to negative infinity. Limit x goes to positive infinity. G of x. I can't write too fast apparently. G x equals. I'm going to go ahead and just do all this. Right? Limit x goes to negative infinity, hx, limit x goes to positive infinity, hx. Don't put equals after the limit. Okay, again, if it doesn't start off looking like this, you're going to be wrong, no matter what you put over here. You gotta write the limit statement correctly. It doesn't have to be perfect, like I said. My h of x is not quite as big as this, but I want to be able to read it at least. The x goes to should be underneath the limit. Okay? Degree on top is less, so we're going to 0. We're going to 0. What color was that? Black. So both of those are zeros. They're both zeros because as I'm just getting closer and closer to asymptote. I don't think you have to do this yet. It's going to, I can do the limit. Because it's a slant asymptote, yes? Yeah. Okay, so it's an asymptote. I don't know where it's at, but it's a linear asymptote. So it's got an x-intercept somewhere, or sorry, yes, a y-intercept somewhere, and then it has a slope. Y'all okay with what I'm saying? And, hold on. I think you're smart enough. No, I don't have to think, I know. Where am I going? This button. Not only is it a linear asymptote, it's a negative linear asymptote. Okay with that? It's a negative slope. It's a negative slope. It's actually a negative slope of 3/1. You just don't know where the y-intercept is. The slope is negative 3/1. We just don't know where the y-intercept is, and we don't really care. Go back here. So it's negative 3/1 somewhere in here. I don't know. Down 3/1, whatever. Doesn't matter if it's here. Doesn't matter if it's here. Doesn't matter where it's at. Because this graph is going to do one of two things. It's either coming down and it's going to hit this thing and go this way, or it's coming up and it's going to hit this thing and then come down. Good enough with all that? So as I'm going to infinity, I'm actually going to negative infinity. And that doesn't matter if I'm coming down this way or if I'm coming up. Either way, I'm getting closer and closer to this line, and we know where that line's going. And as I'm going that way, I'm getting closer and closer to this line, and it doesn't matter where it is because that line's going up to infinity. And so because it's going up to infinity, as I'm coming to it, or as I'm going this way, I'm either coming up and hitting it, or I'm coming down and hitting it. Either way, I'm headed up to positive infinity. And that's what they asked. So I don't have to really know where it is. Let's go back. Let me find this thing. So as I'm going to negative infinity, I was actually going up to positive infinity. And as I'm going to positive infinity, I was actually going to negative infinity. Let me say that one more time just to make sure. We understand that this has an oblique asymptote because a degree on top is one more than the degree on bottom. If it has two more, we're lost. Like, I don't know how to do this type thing. And it's a negative slope because the top is negative and the bottom is positive, or vice versa. If they're both negative, then I guess I don't think they would do that. Okay, so it's a negative oblique asymptote. So as I'm going out there, I'm getting closer and closer to that asymptote, which is going down to infinity. And as I'm going up there, right there, I'm getting closer and closer to that asymptote, which is positive infinity. Oh, this one's nice. I drew it for us. Here we go. Limit x goes to negative infinity. Did they name this one? No? So just name it whatever you want. Limit x goes to positive infinity. These are arrows, guys. I know it looks hieroglyphic. But every one is going to look like this, all right? So here we go. We got limit x goes to negative infinity. Limit x goes to positive infinity. And so I'll call this one f of x. Both of those are headed to 2. These are almost easier than like polynomials, because polynomials you have to think about negative infinity. These are going to asymptotes. This one's pretty easy because it's just going to -1. Again, notice that some middle stuff here, I don't care yet. We'll get there. You guys already know, hopefully, because I know your Algebra 2 teachers. They got you. All right, here's where they talk about slant asymptotes. If the degree on the numerator is exactly 1 greater than the degree of the denominator, the rational function will have a slant asymptote that's parallel. I already told you this. We already know what the slope is, -3/1. We just don't know where it is. So it's parallel to those coefficients. Okay? Has a slant asymptote that's parallel to a/b. And so that's why they put y equals a/bx with no y-intercept of 0. So it's parallel to that one. Woo! I thought I was done with geometry. Okay? So parallel. I know what the slope is, just don't know where it is. We do, we will, we just don't now. Which of the following has a slant asymptote parallel to 1/2 x? And so this is a multiple choice. That's 1, that's 2, that's 3, and that's 4. And then I have one of these choices to choose it when it's parallel to. Does that one even have an oblique asymptote? That has a asymptote at 1/2, right? That has a horizontal asymptote. Horizontal asymptote. Oblique asymptote. Oblique asymptote, I can't say oblique because it's not oblique, it's weird. So the only one that does is 3, and that's parallel to 1/2 because the coefficient here is a 1 and the coefficient here is a 2, and 1/2 is 1/2. So this one has an oblique asymptote that's parallel to that line. First one doesn't have one parallel at all. I mean, it's horizontal. That one's horizontal. This one's not even oblique. Y'all okay with that? Good. I think when you do these multiple choices for homeworks, I think it's very advantageous to you if you have multiple choices for homeworks, not to necessarily know which one's right, but why the other ones are wrong. While you're trying to learn this stuff and while you're doing homeworks, not necessarily which one's right, why are the other ones wrong? And if you can answer that, then you're going to be better for the test than just knowing which one was right. Kind of just think about that as you're going through these multiple choices. Is that the last one? I'm done? Rank this lesson on 5. 5 being the hardest. Not bad? Easier than the warm-up I gave you, right? Okay? So we're going to get to that stuff on the warm-up, but I told you, I was kind of seeing where your mind's at and how much you guys do remember. And hopefully by going over a lot of this stuff today, jogged a lot of those memories. Okay? All right, let me give you